All right, we are live. Live from Orem, Utah. Okay, we're going to move on to chapter 4. All right. Chapter 4.1 deals with exponential functions. Okay. Just to warn you, if you thought the last stuff was bad, we're going to start doing logarithms. Then you guys are not going to like that. But anyway, this is kind of a precursor to that. So let me just start with this. If I have f of x equals 3 to the x power, what is f of 5? So, Daniel, how would you do that?
Put the 5 in the exponent, right?
Yeah, so that would just be 3 to the 5th, which is 343, as everybody knows, right? Okay? How about, what if I said f of negative 2/3? Natalie, what do you think?
So you just plug in that for like 3 to the x.
So 3 to the what?
3 to the negative 2/3.
Negative 2/3. Now, those fractional exponents aren't the funnest, are they?
Yeah.
Could you rewrite that with positive exponents?
Yes.
How?
So that'd be 1 over 3 to the 2/3.
1 over 3 to the 2/3. Okay? Now let's talk about how to simplify this. One way we could rewrite this, if it was the 1/3 power, how would you rewrite that? Or better yet, let's see. You could write that as 3 squared, which would be 9. And then if that was the 1/3 power, how could you rewrite that?
3 to the cube root.
Say it again.
3 to the cube root.
The cube root. The cube root of 9 in this case. Still have our 1 there. Does that make sense? Okay. If you plug that in your calculator, you'd get 0.4807 approximately. Okay? But I do want you to be able to do this kind of stuff without plugging it in your calculator. How about what if I told you I wanted you to graph 3y f of x equals 3 to the x power? Noki, how would you do that?
Graph f of x. I don't know.
What's the fail-safe way that always works? Especially if you don't know.
Look at the exponent.
That's not the fail-safe way.
I don't know. It's not working right now. My brain's just not working.
Would you just T-chart it?
T-chart it? Yeah. Do an XY table. Okay. So since you got your hint from Landon.
Okay, so just plug in values. Probably 0, 1, and 2.
0, 1, 2. You should probably pick some negatives too.
And -1 and -2.
-1, -2. That probably ought to be good for you. So 3 to the 0 is?
0.
Nope.
Oh, 3 to 0. It is 0.
No, it's not.
Is it 1?
It's 1.
Okay, it's 1.
3 to the first?
1.
Nope.
3.
3. 3 squared?
9.
9. There, now we're on a roll. 3 to the -1?
-3.
No.
Negative. Dang. It's not here today. What's that? 1/3.
1/3. There we go. And 3 to the minus 2.
1/9.
There we're now we're on the
Got it.
All right. Now I might, you know what? I might actually use this today. I think this will actually be very helpful. So I'm going to actually use this chart here. Okay. So we're going to just start plotting points here. And we're going to go 0, 1. Okay. 1, 1, 2, 3. 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then we're going to have -1 and 1/3, and -2 and 1/9. Okay. All right. So it's going to look something like this. Okay. Now, am I ever going to hit 0? No. So I'm going to get really close to 0. So I'm going to have an asymptote there. It's a good thing I brought lots of colors today. Okay, does that make sense? All right, so now, can we see that? Oh, you can't even see that on the screen very well. My purple's not very dark. It's a little bit better, but not much. All right, we're going to use something darker, but we're going to use a lot of colors today, I have a feeling. All right, so what if I did g of x equals 1/3 to the x power? How would you draw that, Caitlin? Pick on you, Lucas. We're down to 2 Caitlins today.
Oh golly. Drawing it, it would be, well, it's going to be exponential again, but would it be negative? Like,
I don't know. What do you do when you don't know?
you plot points?
Plot points, right? X, Y table. Okay, what point should I pick?
I like the 0, 1, 2.
Yeah,
negative.
let's just use the same points. 0, 1, 2, -1, -2. 1/3 to the 0 power. We're going to see if you do any better than Noki.
Oh, she'll do better.
1.
1. 1. 1/3 to the first power.
1/3.
1/3 to the second power.
Is that 1/9?
1/9. 1/3 to the -1 power.
Is that 3?
It is 3. 1/3 to the -2 power.
9.
9, very good. All right, so now this looks like it'll be a little bit better, okay? So I've got 0, 1 again, so I'm going through the same point. 1, 1/3, 2, 1/9, -1, 3, and -2, 9. So what do you notice about this?
Is the opposite function?
What'd you say?
Is the opposite function?
Yeah, it's a mirror image, right? Okay. Can you see that on the video? Kind of. I wonder if it would help if I turned off the light. Oh, where are the lights? Over here. It doesn't really, well, it helps a little bit, maybe. Do you want the light on or off? Most of you don't ever watch these videos anyway, right? Who watches the videos consistently? Okay, do you want it on or off?
It's fine, the way it is.
Either way, it is.
Feels kind of
Okay,
nice.
we'll leave it there. All right, so, all right, I'm going to summarize here. There's 2 important things on exponential graphs. I was trying to decide if I should pick another base 3 or something, but at any rate, the 2 important things on f of x equals, and I'm going to just put some letter a, which can represent any number that's going to be your base. raised to the x power, okay? Anytime you have a function, 6 to the x power or 5 to the x power or whatever, okay? The two important, it always goes through 0, 1, okay? You'll notice in either case, we went through that point right there, okay? And 2, you have an asymptote at y equals 0. Now, of course, I haven't done any shifting, but those are going to be your two important points. Now, let me ask you a question. For those of you who are in the back, do you like the light on or off?
On.
On? Is that going to be helpful? Because I don't know that it helps all that much with the... Oh, it's over here. I forgot. Okay. Turn the light back on. All right, so these are your two important things about exponential graphs. It always goes through 0, 1, and you always have an asymptote at y equals 0. Now this is, of course, unshifted. But what we're going to do is now we're going to start introducing some shifts, and we're going to see what happens in this case, okay? So, what if, I'm not going to pick purple anymore. I'm going to erase the purple. Pick a different color like blue. Hopefully this is nice and dark. What if I had f of x equals 1 plus 2 to the x power? My question to you all is, which way do you think that shifts? I guess you got 4 choices. We're going to give you the multiple choices. We go up, down, left, or right. So let's pick on Derek.
I was gonna say up.
Up? You sure?
No.
No? Who agrees with him? Up? Oh, you got a lot of support there. Who disagrees? Okay, it must be up. You're correct. Okay? Going to shift it up. Okay? What if it was a -1? Would go down. What if the +1 was in the exponent? It would go left. And if the -1 was in the exponent, it would go right. Yeah, so you can think of that as being in parentheses, and it's always going to be the opposite. Okay? Question?
What if you have parentheses 2 to the x power plus 1? Would it be the
2
same
to the x power plus 1 like that?
But below, just 2x and then plus 1
2 to the x power plus 1
in parentheses.
like that?
Yeah.
You don't need those parentheses, but it is a good question. Sounds like a good trick question. What does it do in that case? Still goes up 1. Okay? These parentheses you don't really need, right? Okay? All right, so if we were to draw, let's go back to our original problem here. 2 to the x power. We're going to go up 1. So that's going to shift everything up 1. So it's going to shift my important point, 0, 1. It's going to shift it up 1. Okay? So rather than being here, it's going to be here. Your asymptote is also going to shift 1 up. Okay? And let's see. We could do our XY table if we really wanted to. We'll pick all the same points. XY, 0, 1, 2, -1, -2. If x is 0, let's see, 2 to the 0 power is, Fidencio?
1,
1 plus 1?
2.
2, just like I said over there.
Yeah.
Mauricio, 2 to the first power?
2.
2 plus 1?
3.
Alyssa, 2 to the second power?
4,
Plus 1?
5.
Max, 2 to the -1 power?
That would be 1/2.
1/2. So 1 plus 1/2 is 1 1/2, right? And 2 to the minus 2 power, Daniel,
1/4.
1/4 plus 1,
1/4.
1 and 1/4. Okay, so I've got 0 to 1, let's see, 2, 1, 3, 2, 3, 4, 5, -1, 1 1/2, whoops, 1 1/2 right there, and 1 1/4. Okay, so we're going to get close to that. It's going to go like that. Okay? Now, as far as that, it's going to go like that. Okay? Now, as far as grading on here, here's what I'm going to be most concerned about. Okay? Do you have your asymptote in the right place? Do you have the, and I don't have a fancy name for that, I always call it the important point. Okay? The important point is shifted up 1 in this case. Is that in the right place? Those are the two main things, because you can see as my base gets closer to 1, it's going to get wider, and as my base gets closer to 10, it's going to go up sharply. So I'm not really worried too much about the steepness of the slope. I'm looking to make sure you get your asymptote in the right place, and I'm making sure you've got that point in the right place. Question?
So when the +1 is in the exponent, you don't move the asymptote, correct?
You don't what?
Do you move the asymptote or no? You shift the
Oh, that's a
asymptote.
good question. So if I had, in fact, let's do that one next, okay? We're going to use red. F of x equals 2 to the x plus 1. Okay, it shifts it which direction? Shifts it left. Does it do anything to my asymptote?
No.
No, it shifts your asymptote left 1, but who cares? Okay? So in this case, if we're doing that red one now, we're going to try to sneak by with that. So my asymptote's still in the same spot. My important point, rather than being here, is now here. And it's basically going to follow this blue curve perfectly. Okay? So my important point is now -1, 1. My asymptote hasn't changed. Does that make sense? Okay. All right, let's do a couple more. I think I'm going to erase this now. F of x equals -2 to the x power. Okay. What do you think the minus does to it? And remember, you can always do the XY table if you're not sure. So, Keegan, would you like to help me with the XY table on this one?
I would love to.
I knew it. I could tell by the look on your face you knew you wanted to do this one. So, what point should I pick?
-2, -1, 0, 1, 2.
You're going to go in numerical order. Okay, let's start down here though. Yeah, let's do this one first. 2 squared is 4, but it's now -4, right?
Yes.
Okay. 2 to the first power, 2, it's going to be -2. 2 to the 0 power, 1, and it's still going to, it's going to be -1 now, right? 2 to the -1 power. Yeah, with negative would be -1/2, and 2 to the -2 power, -1/4. Okay, so we'll go over here. Where's my asymptote?
Just the same.
It's the same. We're still on the axis here. Okay, so I've got -2, -1/4, -1, -1/2, 0, -1, 1, -2, and 2, -4. So you can see here, what does this negative do to you then? Flips it over the asymptote. Okay? So this is the really important point. Now it's 0, -1, right? Okay? How about, I already did that one. Let's pick a good hard homework problem. How about that? Oh, none of these are hard enough. Oh, this one looks pretty good. How about, this is number 37. F of x, this is number 37. I don't think I assigned it, but it's a good one. I should have assigned it. What was I thinking? 2 to the x minus 4 plus 1. Okay. So Mary, what do you think? How would you graph that?
You do the plotting on the table, the X and Y chart.
Well, we're going to try to do it without the XY table this time.
Okay.
Okay?
Your Y-intercept is 1.
Okay, so normally we would start here, right?
Yeah.
Now, do you want to tackle the -4 or the +1 first?
Yes.
The +1? +1 does what?
To the right.
Uh-uh.
Goes up,
Uh-uh.
down,
Which one?
down,
No.
left.
No.
Okay.
You actually said the right answer, but I was just trying to,
Up
I
1.
was trying to mess you up and it worked, huh?
Yeah.
It moves it up 1. Okay, so rather than being through 0, 1, we're going to be through 0, 2, right?
Yeah.
Okay? And so this +1 also moves my what? My asymptote. So my asymptote is going to be right here, correct?
Yes.
Okay? So everything's moved up 1. Now what does the -4 do me do?
Moves it to the left 4.
Are you sure? No?
Yeah.
Think of it in parentheses, because this is kind of parentheses. And then to the right 4. Okay? It always moves the opposite. So it's going to go 1, 2, 3, 4. Okay, so your important point is at where? It's at 4, 2. Okay? If this is a quiz question tomorrow, that's the point I definitely want to see. Okay? Now, does it go low to high, high to low? Does it flip over?
It goes low to high.
Low to high. Okay, so it's going to go something like this. Okay? Make your point bigger. Yeah. Does that make sense? Okay? The only thing that would have been even better is if I'd have put a negative in front of it. What would that have done? Flipped it over the asymptote. So now it's here, right? Green. Okay, so now it's on the axis. And it's going to go like this. Correct? Question.
Are you going to care about the y-intercept?
The y-intercept, no, not too much. Because usually it's going to be a fraction there, so I'm not too concerned. But if it's on the intercept, then I definitely want to see it. Okay. All right, feeling good about that so far? All right, so all right, so we're going to talk about the most common exponential function that you will see in your, I don't want to say your daily life. You're probably only going to think about this when you get a mortgage or a car loan. But you'll be paying that exponential interest every day of that loan. Okay? So I've got a formula for you here. A of t equals a times 1 plus r over n to the mt power. Okay? This is your compound interest formula. Okay? If any of you have a loan, who's got a loan? Okay? You're using this every day. In fact, the bank's making money off of you right now. Okay? Using this formula. Okay? So let's talk about, oh, I forgot. They don't want an A there. They put a P in the book, so I'll use a P. P is your principal, your initial loan amount. R is your interest rate. N equals the number of compounds per year. T equals your time, which usually means number of years. Okay? Now, if you have a savings account, technically, the savings account, you're making, this is to your benefit, but since they make the interest almost zero, then it's not very useful. Okay? All right. So, let's see here. What if I said a sum of $1,000 is invested at a rate of 12% per year. Okay, this was back in the 1980s. It's certainly not now because your interest rates now are close to, you might get, I think 3% is the best you'll see now. But this was in the 80s when they had high interest rates. Valid. So anyway, find the amount in your account after 3 years if compounded. We're going to do different compounds: annual, semi-annual, quarterly, monthly, and daily. Okay? This is going to be a little repetitive, but what I do want to do is just make sure you can set it up, and then I'm going to hope that you all know how to use your calculator. So, Danae, I've got a Demi in my other class. I almost called you Demi. Danae, can you tell me how you would set this up with an annual payment?
All right, so your 1,000 is going to be your P value.
Okay, 1,000.
And then in your parentheses, you'll have 1 plus 0.12, right?
Correct, 0.12 divided by?
Over, so we're doing annual, so it'd be over 1, right?
Oh, yep, correct.
And then the 1 again is part of your exponent times by 3.
Times 3. Now, some of you suck at putting this in your calculator, and I hate it when you write it down properly on your paper and then you get the wrong answer, okay? So, I want you all to practice, but according to the book, you should get 1404.93. Okay? So everybody practice and make sure you can get that. If you can't, let me know. Give you about 15 seconds to put that in. Use parentheses or you'll get it wrong. Okay?
Got it?
Got it? Okay. So if you have any problems, go to Fidencio. He knows how to do it. Okay? All right. Now let's have Locklear. Can you help me how to do this semi-annually?
1,000 parentheses 1 plus 0.12 over 2,
Mm-hmm.
and then 2 times 3.
Okay? And hopefully you can put it in your calculator correctly and you're going to get 1418.52. Okay? Now look at the difference between annual and semi-annual. How much more money do you make?
14.
Yeah, almost $14 more, right? That's pretty good. Okay? How about if we do this quarterly? Chris, can you tell me what to write here?
$1,000.
1,000
1 plus 112
divided by what?
4.
4?
The exponent is 2.
Mm-mm.
No, 4. So.
It's 4, right? And 3 years, right? Okay. According to the book, you should get 1425.76. Okay. Hopefully y'all can do that with your calculator. What are you thinking about quarterly? How much more are you making over semi-annually? Another $7. Okay. So if you're saving money, what do you want? Do you want to compound more often or less often?
More.
More often. If you're getting a loan, which one do you want? You want less. Which one do you think the bank uses? They use the daily. All right. How about monthly? Who have I picked on here? Jacob, can you help me do monthly?
1,000, and then 1 plus 0.12, 12,
12.
and then 12 times 3.
Okay. According to the book, if you plug that into your calculator properly, 1430.77. And then finally, Breezy, can you help me do the last one here daily?
Yes, so it would be 1,000, parentheses 1 plus 0.12 over 365. And then 365 times 3.
And according to the book, you should get 1433.24. Okay? So the difference between daily and annual is about $30. Okay? All right. So, well, that's almost off the screen. There we go. We got it on the screen now. All right. So, quiz tomorrow is going to be on chapter 4.1. And we'll see y'all tomorrow. Have a good one.
Thank you.